This lesson is going to be about pressure. Pressure is defined as a force per unit area. So the amount of force pushing down on a certain amount of space. There are many different units for pressure. Here in the States, we use PSI, which is pounds per square inch. So what does that mean? For instance, let's say we have a 2-inch by 2-inch square. In total, this square would be 4 square inches. In Laguna Beach, we are at sea level, and the atmospheric pressure at sea level is 14.7 psi, pounds per square inch. If you had this square on the ground and it's 4 square inches, how much atmosphere is pushing down on it? How much atmosphere is pushing down on it? I'll give you a second to try and figure it out, and then I'll show you. So to figure this out, you need to first and foremost know how many inches squared this piece of paper is, and then we can multiply that by our 14.7 pounds per square inch, and that will get the amount of force pushing down on it. So we can do this with dimensional analysis. Start with the given number, 4 inches squared times 14.7 pounds per, that's the line, square inch. And when we do this setup, our inches squared cancel, and we multiply 4 times 14.7, and that would be 58.8 pounds of force. So if you imagine that there is a column of air going from the ground to the atmosphere all the way up, that amount of air would weigh 58.8 pounds. That's what pressure is. All of that pushing down. This is also why when you go up into the mountains, there's less air pushing down. Let's say here, instead of all the way down here, cuts out all of this column of air, and the pressure decreases. That's why when you go up into the mountains, pressure decreases. This is a water manometer, which measures the pressure of the air inside of this flask. So there's air inside of this flask, and there's this glass tube that goes all the way down into the liquid. And I have this tube connected to the top, and if I put more gas molecules into here, it will increase the pressure pushing down on the liquid, and it will go up into the tube. So let me show you. So I'm going to blow on it. And you can see liquid has gone up into the tube. This is water in here. However, historically this would have been mercury, and it wouldn't necessarily be you blowing into it. Like old blood pressure cuffs were made in measuring mercury, so you'd pump it up and the pressure would increase and the mercury would rise up, and what you can do is measure it. So what would happen is there would be a ruler next to the sample, and it'd be measured in millimeters, so the little tick lines, and that would tell you the pressure inside of here. So if I blow a little bit and I get it steady, I could say that the pressure of the air I'm putting into here is roughly 160 millimeters. There are many different measurements of pressure, and these exist on your periodic table down here, pressure conversion. All the pressure conversions start at 1 atmosphere, 1 ATM. Generally, when we're doing things with gases, we use the unit of measure atmospheres, but it could also be measured in this unit, which is millimeters of mercury, which you just saw in the water manometer. Instead of water, you use mercury. Here's the PSI that we talked about. And this last one, kilopascals, is the metric unit of pressure. It's equal to newtons per square meter. A pascal is a very low pressure unit, so this is why you use the kilo, which means 1,000 times it. You should be able to convert between these pressure units. Setting up a dimensional analysis or setting up a proportion.